So I'm Simon Glass. I'm going to talk a little bit about some U-boot things, and at the end a little bit more generally about open source firmware. I just want to say how great it is to be at a conference 35 minutes from my house. It almost never happens. So I don't know how many of you travelled here, I guess quite a lot, but it's quite a wonderful experience. So let's just go through the agenda. I'm going to talk about how things are today. I'm going to mention a thing called standard boot. I'm probably going to ask you if you've heard of it. I'm going to talk about some other things that I've been playing around with or that other people have been playing around with. I'm going to do a demo which is just going to be videos, although I probably could run it on my laptop, as it turns out. And then I'm going to talk about what's next, which is where I sort of throw things out there and see what people think. And okay, so here's the good news. Mainline U-boot has a lot of board support. It's kind of a universal bootloader. It also has some pretty good QEMU support for cloud, and you can run it as an EFI app on x86 and ARM. There's a thing called EFI loader, which is kind of like an EFI layer that lets you run EFI apps on top of U-boot, and it uses Linux device tree, which is great because it's the same schema as Linux. And there's a thing called System Ready, which can boot many distros using that EFI loader. In terms of code quality, U-boot has quite a few tests, and it's got a pretty good CI, and things are definitely better than they used to be when I first started. So yeah, everything looks pretty good. But there's a few problems. One is that the environment is pretty ugly. If you've ever looked, there's an awful lot of environment stuff there that's pretty messy, and I'm looking around to see if there's any water. Do you have water in this room? No. Oh, well. Oh, way over there. Okay, never mind. If I get desperate, I'll walk over there. And then the other thing about it is that EFI is really complicated. There's actually, quite a bit of code involved, and it's, expanding this gap between U-boot and actually booting Linux. Boot Manager is great, but it doesn't really boot quickly. It doesn't, boot from the fast device first, sort of thing. And the device tree is becoming more and more challenging. We think it should be in firmware, but in practice it has to match the Linux that we're running, so we have that problem as well. And we have some secure boot challenges with the device tree as well. And a few other problems are that it's quite easy for generic code to break a board. Oh, thank you very much. You're a star. Yeah, so, and you don't really know because you don't have, with 1,300 boards or whatever, obviously you're not going to have them all. Another problem is that firmware images are getting more and more complex. There are just so many pieces in the firmware. It's not just, U-boot, it's Opti and trusted firmware and all these blobs that come from vendors and everything else. It's really out of control. And U-boot itself can be quite large. So, things are pretty terrible if you look at it from that point of view. It's and this is the way that open source is, I suppose. Things are always on the way to being great, and then you sort of take stock and go, oh, gosh, it's still pretty terrible. We need to do this, that, and the other, right? So my role is basically a vision for better boot firmware. Obviously, it needs to be open source. It needs to be deterministic, so we know what it will do, and very testable. So I'm going to talk about standard boot, and first I want to know who has heard of standard boot? Wow, I'm preaching to the right people then. You've got some, yeah, good, okay, because everyone had said they'd heard of it. I'd probably just go and sit down for 20 minutes, but okay, can't do that then. So I mentioned the scripts before, but standard boot is basically a way to boot automatically. So you start U-boot, it just boots the operating system. It's sort of built into U-boot rather than it being done with these distro scripts. You can still use scripts, of course, but it supports, ChromeOS, Android, and various distros and so on. And it just makes the boot a little bit nicer. And there's a new command called bootflow, which lets you interact with the boot, basically. And I should have mentioned it, but I'll show you later. It can run without the command line interface. So we have a bootdev, a bootmeth, and a bootflow. Bootdev is where to find boot flows. So it's where to find the operating system, which device is it on. And there's only one API call for this, and it's get bootflow, right? Pretty simple. And there's these things called hunters, which can scan things that are slow, maybe USB or other things like that, network and so on. You can run a hunt. You can have a hunter that will go and, dynamically find new boot devs. A bootmeth is a method, basically a method for finding an operating system. The one you're probably familiar with is the extlinux. There's other ones as well. And the boot, if you've got a bootmeth, then you can boot an operating system that needs that. And of course, for most Linux distros, they all sort of have the same approach. And that has a fairly simple API as well. And the last thing is a boot flow, which is really just a C structure. It's basically, here's the operating system, here's the boot dev I used, here's the bootmeth I used, here's the operating system name, logo, whatever it might be. It's just all of that metadata that it managed to collect when it was looking. And you can see there a list of boot flows, basically. Here you've got 0, 1, 2, and there's the boot method and so on. State ready means that you could boot it if you wanted to. So iteration is simple but quite powerful. You scan for the first OS, and then you keep scanning for the next one until you have them all, or you have one that you want to boot. So there is custom ordering and so on, but by default, it'll do fast devices first. And the bootflow command that I mentioned, this is where most of your use is going to be. Basically, here we're saying bootflow info. We've selected, number 0, and we're getting some information about it, and we can see, the command line it's going to boot with and things like that. So that's quite useful just to be able to see what's going on. And you can read the images without booting them, and you can look at them. And here you can see that there's a RAM disk and device tree and so on have been loaded into memory. These are all fake, by the way. This is all test environment stuff. But here's you setting the command line and then booting with that command line. Another thing in part of standard boot is a thing called Expo, which I'll mention later, but basically a boot menu. So a graphical boot menu that doesn't look crap. And it's fairly customizable. There is a sort of a standard thing, but you can mess around with that using this Expo thing. And yeah, a cleaner environment, like I said. There's no distro scripts. It can be just a text file now. If you're used to putting environments in header files, you don't have to do that anymore. And the patch is pretty simple. You take out distro defaults and add boot standard defaults. And then for the header file, you just take out the include of the distro stuff. And that's, for most boards, that will get you running. And I'll be gone by the time you find out that's not always true. So another good thing is it's got 5,000 lines of tests. There's an awful lot of stuff in booting that is just never tested. I think I broke something in U-boot to do with PXE or something, and no one noticed for months. It was maybe a little bit of an obscure feature, didn't have any tests, So with this effort, definitely trying to get test coverage. This test is basically scanning for an OS, obviously booting it. It's actually an EFI OS, so it's going to then look for exiting boot services. It's going to make sure that it did actually shut down the devices, because U-boot's supposed to do that when it gets that call. And then it's going to check some memory allocations to make sure that, we got the memory allocations we expected. So there's the documentation link. In terms of migration, there's some boards are in there. There's some that have been pending for quite a while, but it's able to be migrated to, put it that way. Okay, now I'm going to talk about a lot of other things related to the problems I brought up. Eventually. There it is. Okay, so the first thing is the command line. Obviously, it's great having a command line, but when you ship the product, maybe you don't want the command line, or maybe it's big and you just would rather not have it. To date, you generally need it because if you don't have it, you can't boot. Because you're using scripts, because you're using the bootm command and so on, can't be done. So as part of standard boot, that limitation's gone away to a large extent. It's not complete, but you can boot most things now just with the command line totally disabled. So when U-boot starts, it literally does a programmatic boot, boots the first thing it finds or whatever, however you've set it up in the environment, and off it goes. So, and for example, QEMU x86 reduces quite a bit from that with that change. Another thing I was playing around with recently is booting really quickly in the cloud. So if you're trying to boot a Linux in a KVM, QEMU KVM or something like that, and you don't really want the firmware to sit there taking forever to boot, how quickly can it boot? So I did a bit of playing around and I found that it can boot in around 82 milliseconds, on my machine at least. That's U-boot's runtime from that to handing off to Linux. And you can see a post about that if you're interested. I'm going to do a little demo of it a bit later. And Expo. So I mentioned that before. Expo is a stupid name. It's just trying to be slightly unique. Whenever you look in the source code, you're trying to have something that isn't called, I don't know, screen or display or whatever, So it's called Expo as a sort of an exposition of something, right? And within each Expo, there are scenes. You can have several scenes, and a scene might be, here's my boot menu, or here are my machine settings, and you might be able to flip between those scenes, sort of thing. So that's kind of the idea behind it. It also has the ability to run in text mode, which is somewhat implemented for serial and so on. So that's that. And then the other thing to mention is the EFI app, which has been getting some attention. It was written a long time ago, I think 10 years ago. So I remember doing it for some Google network switch or something. And now it's getting a bit more attention. And there's also an EFI stub, and some of the Qualcomm devices are using that. They literally boot into U-boot, takes over the machine and goes from there. So that's another way of doing it. Here's my lab. So this is probably the ugliest lab picture you'll ever see in your life. Cables everywhere. The purple ones are networking. But it's basically, as I discovered after I did it, my daughter's old bookcase. She said, I wondered where that went. And it's very helpful because I can attach things to it. And I've basically hooked up this thing. I used a thing called LabGrid. Have people heard of LabGrid? Yeah. I think it's really good. And it does a good job of this. And I can basically type this on my computer and it will boot me into, U-boot on whatever board I type. It's pretty nice. And then I thought, could we hook it up to CI? Because it's not very useful if only I can do it. And so some of these boards are in CI, and you can push, when you push something to it, it goes off and runs these tests on the board. This is showing a failing test. It's failing because the MMC card is crap. But that's an interesting integration. And it basically works just using a GitLab runner and kicking off a LabGrid session. It's not very difficult to connect. Have a look at that if you're interested. Okay, and I wanted to say a little bit about BinMan. So BinMan is about firmware images. And basically, as I said before, they're getting more and more complicated. Binman is basically an attempt to try to get a handle on that, to try and put a schema for it, try and figure out what's in there and so on. So you describe the image, and I've got this really naughty example here. We've got some empty bytes. We've got BL31, we've got SPL, we've got U-boot, And it can be arbitrarily complex from there, but that's probably the simplest example I can think of. But you think about it, you're creating that description of the image, and Binman will just build it for you. And the nice thing is that if there are external blobs or whatever, you can pull them in as well. So if you want to play around with that, that's the pip package. It's available in U-boot as well. And the other nice thing is that Binman can fetch some of the tools. Like, for example, the Xilinx bootgen tool I didn't have, so I can just say fetch and it will go and build it and give it to me. I have a real bugbear about people saying, oh, here's how you build an image, and then there's about 20 pages of documentation, download zip files, install my massive operating system so that you can, all this sort of stuff. No, just make it really simple and make it automatic, and that's the goal. What Binman does not do is go and find blobs for you. So you still have to go and hunt those down, but I'm hoping one day that we can improve that situation too. So here's a couple of demos. This is just showing standard boot, and I'm sorry that this is not going to be enormously large, and you'll see some of my videos are better than others. But here I'm running a boot script. I'm giving it a disk, a root disk, it's the x86, and I'm turning on KVM, and I'm sending a kernel and an init into QEMU. Okay, and then I'm going to look at what boot flows are available. So I run boot flow scan, and you can see it's found 3. And I'm going to list them, and then I'm going to select number 2 and have a bit of a look at it. So I'm going to read it in first. So now I've got the files in memory. I can look at them, see them all there. And then if I want to, I can look at the information. I can see the command line that it's going to use. But I want to add a serial console. I want it to boot serial console in this particular case. So I just say set console that, and I've typed that wrong, but it still works. Critiquing your own demo video, and then you boot it and it boots, right? So that's sort of the interaction with boot flow, and so I hope you can see it's a much more high-level interface than bootm and load, and all the addresses are sort of not taken care of for you. And then the second thing I did, while I was talking, was I just ran it again without doing anything, and it booted automatically. In this case, using EFI to boot Ubuntu. So that's that. The second demo is about booting Linux in 100 milliseconds. So here I'm building U-boot, just building it, and now I'm going to run it. Okay, so that you probably saw the banner flip pie, but it was pretty quick. But then I found someone did a script which lets you use perf tool to measure the time that U-boot took to boot. And so it's basically using postcodes on x86, and you send one when U-boot starts or when QEMU ends, and then you do another one when U-boot finishes, and it's 82 milliseconds. So that was the demo of that. And the last one I want to show you is, this is my lab. Here I am connecting to a Beagle Play board. And the interesting thing about this board, has anyone got one of these or played around with this? Yeah. It's actually got 2 different ARM chips in it, well, at least. And there's 2 different U-boot builds for it, which is kind of weird. And so here it is building both of those things, putting it into this complicated firmware package that I showed you before, right? The types of things that we're going to have in there, and you'll see it in a second in this video. But there it is booting into the machine, and so this is basically the image that's running, and you can see it's a fit. It's got all these things in it, ATF, OPT, all that sort of stuff. But it's also got another image for the other machine, which has secure boot stuff, signed stuff, all this kind of stuff. It's pretty complicated to put together, and Binman does that just when you build U-boot automatically. So I think TI has definitely been a leader. Texas Instruments definitely been a leader in this area, but other vendors are doing it as well. It's NXP is doing things there too. Okay, so that's my attempt to try and make things a little better. Obviously, it's work in progress. My wish list, though, more generally, is that we have an open source boot from reset all the way up to when you're booting your operating system. I'd like to have open standards and APIs. And, in my opinion, having a GUID, which refers to a protocol that's implemented by Lenovo, is not an open standard. I'm talking about something that's actually documented, right? Gosh, I don't want to race against the other people. They've obviously already finished. So basically declare the boot flow in advance. What I mean by that is I want to know how this thing's going to boot. I don't want to have to boot it to find out. And you'll probably see a bit more about what I'm getting at there in a minute. So what about EFI? Let's just look at how things work in the boot and how we got here. And I'm going to go back a little bit, but the task we basically have is to load some files, right? Set up a few tables like ACPI or whatever, and then start Linux, and then have a drink of water. So do that. Okay, so the things we have to do this are the firmware, some interfacing, which you'll see in a minute, and obviously the kernel. So going back to 1995, which was actually before I got into this, but I did look it up, we had a BIOS, we had maybe Lilo or something like that, or maybe we just jumped straight into Linux. But there really wasn't very much. It was pretty simple back then. And 10 years later, when I'd been in it for a little bit at that point, we had a thing called U-boot, we had a thing called Canonical, and maybe we were using Grub. But the interesting thing is that the kernel has a serial decompressor, has some serial output. I don't know if anyone old enough to remember, it would say decompressing Linux, and a whole lot of dots would come across, right? Yeah, you're actually in Linux at that point, sort of, but really you're in this interfacing code. Okay, so that's that. And I don't think things changed awfully, but this is wildly inaccurate. I'm just giving you a picture, right, of approximate picture. But, I don't think things changed an awful lot in the next 10 years. But then in this year, when I look at it, we have a lot of different things here. We have shim, for secure boot, so that we can actually boot on a device if it's using that. We have Grub. Maybe we're using these UKI things, and we've got systemd stub, which is kind of an executable header on the front of the package. And then when we get to Linux, no, we're not Linux, we're just still in this EFI app that's sitting at the front of Linux and is doing some stuff. And then finally we get to Linux. So there's a ton of interfacing. And when you look at this, it's quite interesting. All of these things are linked by EFI. So you have a situation where here, when I'm in the Linux EFI stub, if I want to read a device tree or something like that, my call is going all the way back to here, through this system table thing and so on. So that's just the way EFI works, and nothing particularly wrong with that. But it would be better if we knew that we needed it before we booted past it. Do you know what I mean? We're saying, right, let's go. And then we're going, we need all the stuff, Don't worry, we can get it. We can call back and ask for it. Okay, it doesn't seem to be quite right to me. And if you look at the size of these things, it's not trivial. Grub's, that's with all the modules, admittedly, with a lot of the modules. But, systemd stub is 150K, and these things are all growing. The EFI stub, from what I can tell on Linux, is pretty small. The other thing is that we have to use FAT. Why on earth are we putting things on a FAT file system? Because it's in the spec, because that's the only thing you can rely on. Canonical does it. U-boot supports ext4, Grub supports ext4, but Canonical doesn't seem to properly or something. I don't know. Most of the vendor forks don't. And then, it's this lowest common denominator thing. And I've had many discussions with people over the years. We can't do this because there's this other bootloader that doesn't know anything about anything, and so we just have to be able to do everything for it. And that's not where I think we should be. We end up with all this added logic here, basically going into these different things. And so if I stand back and go, how is this thing booting? How does it boot? You tell me. I don't know. Do I have to go and look in this code here to see what it's actually doing with, I don't know, measuring into PCRs and stuff? I mean, we really need this to be a bit cleaner and a bit more sorted out. And in my view, this intermediation, this separation of firmware and the kernel is really not it's really not a good idea. So, and we understand why it happened, right? It's because the business model, it's just the way that it works. Some of these things are very hard to change. But this isn't a historical thing. This is happening right now, and this is the way that booting will be unless we change it. So, it's I'm not talking about things that are being solved right now. I'll just mention Linux, the flat image tree. And perhaps I could ask, who's heard of that? Okay, well, most of you. Well, I guess it is a U-boot talk. But the nice thing about it is it handles device tree automatically, and it's now a separate spec from U-boot because there are other projects using it. Canonical uses it, for example, with the universal payload specification, and Coreboot has support for it for a while. And there's other projects that use it, so it's now out in a separate little place. It's similar a little bit to UKI if you haven't heard of FIT, but a little bit different. Doesn't require EFI. And if you try Linux, you can build an enormous FIT in Linux on ARM64 these days, with something like 1,300 device trees in it or something like that. It'll boot on absolutely anything if you've got, 12 megabyte. Don't mind a 12 megabyte thing. But anyway, yeah. Of course, that could be fixed with overlays. So what could we do instead of callbacks? I keep talking about these EFI callbacks, but I haven't provided an answer. I think, to me, it's a simple thing of tell me what you need. Tell me Linux. Do you need some random numbers? Do you want to be moved around in memory? What are you actually looking for to happen here? Just tell me. Just put it in the metadata, and I'll do it before I jump to you. I don't want to have 120K of code sitting there so that you can call back when you finally figure it out. We know at build time what it's going to want to do, right? And I'm sure there's details to work out, but I think that's the gist of what I'm saying here. Overall, I think that too much of this stuff is designed for closed source, and that's fine. I mean, it's just the way of the world, right? But we should be open to making changes that are better for open source. And thinking about open source first, rather than how do we squeeze. We've got all these blobs everywhere. We want to put this little open source bit in here, and we want to make it work. I really don't like the lowest common denominator thing, and I hope we can get away with that. I hope we can get away from that and say, no, you have to have ext4, or you have to have these basic abilities, like loading different formats and so on. Because we do live in an open source world, and if you haven't noticed, the world's been taken over by open source. It's kind of amazing to me when I look at just some of the services that you can run on a cloud and that sort of thing. Massive projects all over the place, and firmware shouldn't really be any different. This is my view of what I hope we might have in 10 years. Some sort of root of trust, sort of A/B recovery thing here. I don't know what that looks like, but it might be very secure. And then we're going into U-boot or maybe some new GPL firmware. I haven't played around with Zig, but that looks pretty cool. I don't know. And there's a UPL specification that I mentioned that allows these firmware things to communicate. Look up that if you're interested. And no interfacing at all, and the next thing that happens is Linux is running. So that would be my my dream. I would retire. That happened. And just, here are the boot features I support. That's basically what you want out of the firmware, right? I can do this. So you're installing an operating system, you look at what it can do, and you go, right, I'm going to do that. No problem, you'll be able to boot. And the OS says, here's what I need, no problem, I'm going to give it to you. And off we go, So yeah, just a bit of a summary. Try migrating your boards to standard boot if you're interested. Have a look at BinMan. And I think booting is, unrecognisable even from 10 years ago, but I think it has a bit of a way to go. And I hope we can head it in the right direction together. So very important, if you have any comments or feedback, please get in touch. I would like to be part of the solution, but I'm only one person. Thank you very much. I guess we do have time for questions if anyone wants to ask one. You might have to get the microphone.
How does boot standard compare against Falcon boot in terms of overall boot speed?
So, in all honesty, the difference between having scripts and not is not massive. The commands that it's written in C, it's on a fast CPU, it doesn't really matter that much. Often the reason that U-boot itself is slow to start up is because it's doing pin control, looking up all these things before relocation when everything's slow. So, I could run the ROC 5B, I'll do that in a sec. I can show you that. Basically, it boots right through all of that really fast, like probably milliseconds to get to the U-boot proper with the cache on. Anyone else? I'm doing my own running with this mic. So you people in the middle can't ask a question. If not, we'll close it. I'll do that I'll show you that ROC 5 thing. Thank you very much for coming, everyone. This is just showing my lab booting ROC 5B, and if you did watch it, you'll see eventually it'll come up, and it's pretty quick. So did you see, you probably noticed there was a bit of a delay after it did the U-boot banner. That's what I'm talking about. Some of these boards have way too much stuff going on just to get a serial port going before relocation. Definitely an area for optimization.